Hi, I'm Sean Smith, President and Head Tool Design Engineer for Smith Machine & Tool. Today, I'll be going over Smith Machine & Tool's drill press cutting tool and portable cutting tool. I'll go over the general components in our tool, how to cut a bearing using these tools, and a general maintenance guideline. While the tool I'll be showcasing in this video is part of our standard bearing size inventory, Smith Machine & Tool also offers custom tooling, both stocked as well as made-in-a-day options for various applications, based on difficult part configurations, tight clearance situations, rib sections, reduced clearance areas, or custom-sized bearings. The SMT drill press cutting tool is used for cutting the chamfer lip of an installed V-groove bearing in order to properly remove the bearing from a housing hole and the reuse of the housing. It's important to use a heavy-duty drill press because it ensures enough force can be applied into the bearing without deflection in the drill press quill or column head of the machine. It is not meant to be used in a typical Harbor Freight or hardware store table-mounted drill press. If the tool is used on those drill presses, there is potential for damaging the tool, the bearing, or the housing due to the lack of rigidity in the machine. You also may not achieve the swedge required for aerospace standards. Now, the tool consists of a couple main components: a drill press cutter that features a 1/2-inch shank for use in a heavy-duty drill press, and a first side flat swedge base to locate the bearing. To use the SMT drill press cutter to cut the bearing, you're going to first install the drill press cutting tool into the arbor chuck of a heavy-duty drill press. Ensure that the part is securely fastened to the mounting plate of the drill press, as an unsecure part may cause damage to the part or injure the operator. Then, set the speed of the drill press between 50 to 100 RPM or the lowest RPM setting on your drill press. With the machine off, adjust the stroke of the quill in order to not overcut the bearing. The drill press cutter should engage the race and lip of the bearing no more than 30 to 60 thousandths of an inch. Next, lubricate the teeth of the cutter with a cutting lubricant. Also, apply a small amount of lubricant to the face of the bearing. Turn on the drill press machine and slowly feed the cutter into the face of the bearing. Observe the chip formation to ensure that the chips remain non-discolored. A dark or blue chip will indicate that the machine is running at a too high of an RPM or that you're feeding too fast into the face of the bearing. A gradual peck feeding is allowed between 5 to 10 thousandths per peck. Between pecking cycles, brush and remove chips from the cutting teeth and the face of the bearing. Make sure that damage is not being caused to the housing during cutting by observing the racetrack that is being formed by the cutting teeth. A full depth of cut is made when the V-groove toward the outside diameter has been completely eliminated to the bottom of the vertex. Finally, when the full depth of the cut is made to the bearing, retract the cutter, turn off the machine, and proceed to use the SMT removal tool to extract the bearing. When you're finished using the drill press tool for your job, you should take the tool apart and clean it. We recommend using WD-40 lubricant to prevent rust and corrosion to the tool and flat side base. Following these proper general maintenance steps is important because it extends the life of the tool and ensures quality for the next use. Cutting tool damage can possibly be repaired. Please contact SMT for any long-term wear and tear on the tool for regrind. Now, if you need to safely remove the bearing from a housing hole in order to reuse the housing, a portable cutting tool is safer for an operator to use. There is less risk involved, but it is more time-consuming to remove a bearing. To cut a bearing with the SMT portable cutting tool, first insert the guide rod through the bore of the bearing and attach the anvil support onto the guide rod and fasten tight with the rotating flange nut. Do not over-tighten the rod and flange nut as it might damage the guide rod. Only tighten as necessary in order to avoid rotation during cutting. By tightening the guide rod and the flange nut, the bearing bore should now align perpendicular to the face of the bearing. Next, attach the cutting tool to the opposite end of the guide rod with the teeth facing the bearing race. Install the rotating flange nut. Apply a small amount of cutting oil to the teeth of the cutter and to the face of the bearing. Begin gradual tightening of the flange nut on the cutting tool side until the cutter becomes difficult to rotate by hand. Use the provided wrench to begin rotation of the cutting tool. Rotate the cutter 3 to 4 rotations before applying more pressure by tightening the flange nut on the cutting tool side. The cutting tool should only be rotated 360 degrees at a time before the next sequence of cutting rotations is applied. Continue cutting until the cutter has reached a depth of 30 to 50 thousandths. Then the cutting tool can be removed in between cutting sequences to observe the cutting progress. A full depth of the cut is made when the V-groove toward the outside diameter has been completely eliminated to the bottom of the vertex. Disassemble the cutting end of the portable cutting tool and clean the face of the bearing. Loosen the anvil support side flange nut and guide rod and remove the entire cutting tool assembly. Lastly, use the S&T removal tool to extract the cut bearing. Just like the drill press cutting tool, when you're finished using the portable cutting tool for your job, you should take the tool apart and clean it. The S&T portable cutting tool consists of a guide rod, V-groove anvil support base, rotating flange nut, and cutting tool. When you're finished with the job, ensure all FOD and debris has been cleared from each of the tool's components. Then apply a thick viscosity high pressure grease to the bearing journals of the guide rod as well as all threaded surfaces before and after each use.